Okay. So, distance based method, we have to go for 3 steps. One is using DNA test. We have to give input and we will get out file, and that out file will be renamed as in file, and we have to perform neighbor method, and that neighbor method will give you 2 files. One is out file and out tree. So, we have to rename that out tree as in tree, and next step is we have to create phylogenetic tree, rooted tree using drawgram and unrooted tree using draw tree. Similarly, for character based method, we have to use DNA ML, and the output of DNA ML will be used as in tree for drawgram and draw tree. So it has the distance based method will have 3 steps, and character based method will have only 2 steps. So this is with respect to filing. I want all of you to perform an multiple sequence alignment by selecting few sequences of your own interest, and after that you have to come up with a Phylip format output, and that output will be used as input for phylogenetic tree construction. So this exercise is over. So next we are going to proceed with another experiment, that is homology modeling using Swiss modeler. So it is a very easier exercise to perform, that is Swiss modeler. So for Swiss model you have to give, you can Google it as Swiss model. So as you can see, it is a server which is fully dedicated to produce or to create a protein structure, that is in vitro. So you will have a template and you are going to produce the structure of a protein which doesn't have structure previously predicted. So you are going to predict a structure and you are going to use that structure for your studies. So I am having a protein sequence which is a novel sequence. It doesn't have any structure being found and deposited. So for that I am going to search for template, that is any protein which has similarity with my new or novel protein. So I have to search for template. If template is present, then I am going to model the structure for new sequence using this homology technique, which is similar to Xerox. Like what we do in Xerox, we will be giving a paper and they will produce an exact copy as like in the Xerox. So that original will be a template and new copy will be your model. So it is another new version. So this is homology modeling. For that you have to click start modeling. Once you go to this page, click start modeling and you have to paste your target sequence or UniProt KBAC here. So as you all know, we have already performed an experiment in UniProt which is about protein sequences. You will get complete protein sequences using this UniProt. So for that you have to go for UniProt KB and you can click for any protein of your interest. For the time being, I am going to give hemoglobin. So I am going to take this particular protein. And one advantage of using this Swiss model is, instead of going for FASTA sequence of this particular protein, which you will get here. So instead of copying and pasting all these sequences, I can copy the ID number, that is UniProt ID number. You can get the sequence being displayed. So this is my sequence and one model is available in Swiss model repository. So already the model is available. You won't get this message for a new or novel sequence. So since I am going to use this sequence as a trial, you will get this message. Okay, so I have to search for templates, and even you can give your mail ID. When the work is done, you will get a mail that templates is being found. So it is still running. If you want, you can give your mail ID and you can close this window. Once all the work and template is found, you will get a message in your mailbox, and from that link you can directly open this particular page. So all the process being running, so you can see it is currently running. So let us wait for this to complete. Okay, so this is my output page. As you can see, for this particular hemoglobin subunit, I got 50 templates. That is 50 structures are already available for this hemoglobin sequence. So from this, I can select any of the structure I want and I have to build model. So by default it has been selected this hemoglobin gamma chains. So I am going to click build models. Once I click build models, I will be getting a new model structure that is being predicted for my sequence. So from the first, I have selected one particular protein and I have typed that protein as input in UniProt, and in UniProt I have collected the accession number or the name or the number given to that particular protein, and I have given that number as input in Swiss model, and I have to find for templates. After template finding, I have to build model. So this is my newly predicted model for hemoglobin. So here you can see a 3D visualization of the structure, and you can change all this structural features, like you can change it as helix, cube, ball and stick, lines. So you can change all this, and you can take a snapshot and you can play, like you can rotate, and once you move the mouse you will see all the residues, like this is proline and this is valine. So you can stop. Okay, so what are the other parameters I want to see is I have to check for sequence identity, which means I have given a sequence, there is already a structure in the database, and my sequence and the sequence in the database is 99.32% identical. So this is a good model to be used as template. And the ID of the structure which is present in Swiss model or PDB. So this is all about homology modeling. So in simple, homology modeling is very easier technique to predict the structure of a novel or a putative protein, which means the protein which doesn't have any structure being predicted or found using any methods. If there is no structure for a protein, it is known as novel protein or putative protein. So I have built a model, or I have built a structure for my target protein using a web tool, that is Swiss model, using homology modeling. Homology modeling means comparing two similar sequences, and if my sequence has similarity with the sequence in the database, then the structure of that sequence will be used as template and I will be creating a new model. So this is homology modeling.